The cephalosporins were first developed in the 1960s as a response to ampicillin-resistant, penicillinase-producing Staphylococcus aureus. As new compounds were developed, a large, multi-generational drug class emerged. The cephalosporins, along with the penicillins and carbapenems, are members of the beta-lactam superfamily of antimicrobials. These drugs are all cell wall synthesis inhibitors, and they act by binding to the penicillin-binding proteins in the cell wall. These transpeptidases and carboxypeptidases are involved in the final stages of peptidoglycan cross-linking in synthesis. Consequently, these drugs are bactericidal, and their activity relies on actively growing cells, so they don't work well on bacteria in stationary phase. For a more detailed discussion of this, see the video on penicillins linked above. Cephalosporins are commonly grouped into generations, from first through fourth. Our first generation drugs were developed in response to the emergence of penicillinase-producing Staphylococcus, as I mentioned in the intro. This family includes cefazolin, cephalexin, and cefadroxil, and these have good activity against gram-positive cocci and some gram-negative enterobacteriales like E. coli, which do not produce beta-lactamases. Our second generation cephalosporins, drugs like cefuroxime and cefaclor, have improved gram-negative spectrum and retain activity against organisms like E. coli, which produce narrow-spectrum beta-lactamases like TEM1. These drugs retain activity against gram-positive cocci and also have improved anaerobic coverage. Our third-generation cephalosporins, drugs like ceftriaxone and the veterinary products cephalosporin and ceftiofur, have greatly improved anti-gram-negative activity, including those E. coli-producing narrow-spectrum beta-lactamases. Some of the third-generation cephalosporins also have activity against the spice organisms. SPICE is an acronym which stands for Serratia, Providentia, indole-positive proteae, which is Proteus vulgaris and Morganella, Citrobacter, and Enterobacter. This group of organisms is important because they intrinsically produce AMP-C beta-lactamases and are intrinsically resistant to many of the beta-lactams. It's important to note that only some third-generation cephalosporins retain activity against gram-positive organisms, and so you need to be aware of the properties of the drug that you're planning to use. One example, cephalosporin, a veterinary product, retains excellent coverage against gram-positive cocci. Our fourth-generation cephalosporins, drugs like cefepime, have excellent activity against gram-negative rods, and many retain good activity against gram-positives as well. The way that I like to think about our cephalosporin generations is that as we increase in generation from first to second to third to fourth, we have improved activity against gram-negative bacteria as we see increasing resilience to gram-negative beta-lactamases. Finally, I want to briefly mention the cephamycins, drugs like cefoxitin and cefatetin. While not technically cephalosporins, these are cephamycins, have many of the properties of our cephalosporin drugs. They have good activity against gram-positives and gram-negatives, which produce narrow-spectrum beta-lactamases, and they also have excellent activity against anaerobic bacteria. I hope this summary of the cephalosporins was useful, and if you have any questions, put them in the comment section below.